Hi, I am Professor Jesús Toribio from the University of Salamanca in Spain. The title of my presentation is Hydrogen Embrittlement of Pearlitic Steel in the Presence of Cracks, a kinematic fracture criterion based on the crack tip strain rate, the local strain rate at the crack tip or its vicinity. I am with the Fracture and Structural Integrity Research Group of the University of Salamanca, the oldest in Spain and one of the oldest in Europe. This is the beautiful logo of my university. I am going to divide my talk according to the following outline. First, introduction. Second, crack tip strain rate. Third, experimental program. 4, fracture criterion. And 5, conclusions. First of all, the introduction, the motivation. It is well known that environmental assisted cracking, EAC, or in traditional terms, stress corrosion cracking, SCC processes, depend markedly on kinematic variables such as the strain rate. The dependence being non-monotonic for localized anodic dissolution or pure stress corrosion cracking, and monotonic for hydrogen embrittlement or hydrogen-assisted cracking. When pre-cracked or notched specimens are used to study environmental assisted cracking, the local strain rate at the crack tip, it is the crack tip strain rate, is the variable governing the process. It is the local strain rate just at the crack tip or in its vicinity, the so-called crack tip strain rate. Second, the concept of crack tip strain rate. This is the schematic of the crack tip. In this paper, the traditional solution in linear elastic fracture mechanics is used. Here we have the polar length R, the polar angle theta, and the vertical coordinate Z, CT, and the displacement, the vertical displacement VCT, and the local reference length LCT, crack tip length. According to this schematic, we compute the crack tip strain rate as a time and space average of the local strain rate at the crack tip or crack tip strain rate. This instantaneous value of the crack tip strain rate is averaged over time from 0 to critical time to failure during the test, and in addition, it is averaged over the critical distance. Then we use the critical distance concept, CDC, or the concept of zone affected by hydrogen. In case of pearlitic steel, is the so-called tearing topographic surface, TDS zone. With this average of space and time of the local strain rate at the crack tip or crack tip strain rate, we apply this definition, this concept, this computational method to the results of an experimental program on pre-cracked samples of pearlitic steel tested under hydrogen embrittlement environmental conditions. This is the experimental setup with a potentiostat at a 3-electrode assembly, reference electrode, saturated calomel electrode, a salt bridge, platinum counter electrode, and the sample as a reference electrode. We use a cathodic potential, minus 1200 millivolts versus saturated calomel electrode, just to promote hydrogen embrittlement, hydrogen-assisted cracking, environmental conditions. This is a plot of macroscopic experimental results as a plot of failure load in hydrogen, FC, critical load in hydrogen, divided by the reference value in fracture in air with no hydrogen assistance, versus the displacement rate in meters per second. We observe the typical increasing monotonic trend of any hydrogen embrittlement, hydrogen-assisted cracking test when tested against the displacement rate, the crosshead speed, or the global displacement rate. There is an increasing trend. The higher the displacement rate, the lesser the effect of hydrogen, because we have less time for hydrogen entrance, penetration, and diffusion into the sample, and less time for hydrogen-assisted damage or for hydrogen embrittlement. Then Let's formulate a fracture criterion on the basis of the local strain rate at the crack tip, or local strain rate in the vicinity of the crack tip, the so-called crack tip strain rate, CTSR. This is a sort of kinematic fracture criterion on the basis of this local crack tip strain rate. This kinematic fracture criterion for cracked sample is formulated by using two dimensionless variables plotted one against other: the dimensionless stress sigma asterisk and the dimensionless strain epsilon asterisk. Sigma asterisk is computed on the critical loading hydrogen-assisted cracking test, normalized dimensionless form using the depth of the hydrogen-assisted microdamage region, the TTS depth, and the extension of this area. With regard to the dimensionless strain, it is computed as the space and time average of the crack tip strain rate, of the instantaneous value of the crack tip strain rate. This instantaneous crack tip strain rate is averaged over the hydrogen-assisted microdamage region, the so-called tear in topography surface, and also averages in time from 0 to the time to failure in the hydrogen-assisted cracking test. We again have an increasing trend, and to check the validity of this approach, these results with a single curve are compared with results from notched samples of the same kind of steel. Here we have the results from notched samples. They will be explained in another presentation in this conference, but again in dimensionless terms, dimensionless stress computed using the average value of the TTS region, and dimensionless strain crack notch tip strain rate average in space and time, average over the tear in topography surface in space and over the test duration obtained to failure during the test. Here we have a universal curve independent on the geometry, 4 different notched geometries with different levels of stress triaxiality, a common curve, and 4 different asymptotic values depending on the triaxiality levels, BHCD, resembling BACH, the number of Johann Sebastian Bach, the most genius, the best musical composer ever. Going back to the results from pre-cracked samples, we have similar curve, and the two universal curves approach each other, thus demonstrated the validity of the present approach of a kinematic fracture criterion for pre-cracked samples. Let's go back on the basis of the crack tip strain rate. Let's go to the conclusions. A simple method was proposed to estimate the local strain rate at a crack tip, or crack tip strain rate, on the basis of approximate stress distribution in its vicinity. Stress and displacement distribution, the crack tip stress distribution and the crack tip displacement distribution, crack tip stress and displacement fields. The procedure is fully analytical, is approximate on the basis of linear elastic fracture mechanics principles, and thus it presents clear advantages of simplicity over traditional numerical methods. 3. The estimated values of the crack tip strain rates were applied to the modeling of slow strain rate tests on pre-cracked samples under hydrogen embrittlement environmental conditions. 4. Results of the model agree fairly well with previous modeling of hydrogen embrittlement phenomena on notched samples of different geometries. 5. These results confirm the very important role of the local strain rate at the crack tip in hydrogen embrittlement or hydrogen-assisted cracking in the presence of stress or strain concentration. The level of triaxiality constraint of the specimen geometry influences the kinematic results in hydrogen-assisted fracture. And that's all. Thank you very much for your really kind attention.